Good morning, people. So I'm going to talk about the evolution of geo-replication in Gluster FS, and to start with it, I'll give a brief idea about what Gluster is so that you can understand the rest of the talk. And yeah, Gluster is a distributed file system with no single point of failure. We don't have a metadata server, and that's how we achieve this no single point of failure. And it provides easy scaling out, and it can run on any commodity hardware. You don't have to buy boxes to run Gluster. And it provides other basic file system features like replication, erasure coding, and stuff. And the terminologies that you have to know with Gluster are bricks. Bricks are basically your disks which you are going to make use to store your data in the backend. And servers are going to be collection of your bricks. And a volume. Volume is a logical entity which is going to have a collection of bricks across various servers. And then your client, that's where you write your data, and that data is going to be transferred onto your bricks. And the trusted storage pool. It's a collection of servers within which you can perform certain operations and manage it. So the overview would be something like this. So you have bricks in your server, and these bricks together form a logical entity called a volume. So I'm going to talk about the evolution of geo-replication in Gluster FS. And so yeah, about geo-replication, I'll give the basic requirement for geo-replication so that you can understand the rest of the disaster recovery. And with replication, your data is going to be on your side, no same data center, and we don't have a metadata server, and that's how we achieve this that much reliable when it comes to natural calamity. So we go for easy scaling replication where you can replicate your data on any commodity data centers. You don't have to buy boxes to run Gluster. The requirements for geo-replication are basic file system features like replication, erasure coding, and stuff. Gluster volume, and the terminologies that you have to know with Gluster are bricks. So bricks are basically your disks which you are going to have, and also the other requirements to store your data in the backend. Checkpoints to know until when your data is actually collection of your bricks from the and a volume. Volume is a logical entity which is going to have a collection of bricks across various servers, copying as efficient as possible to reduce the you write your data, and that data is going to be transferred on the master volume. And how we did it is storage basically we have a collection of servers within which you can perform the master volume where you are actually writing your data from the master volume. So the overview would be something like this. Data is copied onto your slave. Bricks in your server, and we basically create together form a logical entity called a volume, and that volume is mounted on a client where you have to record the changes that are going in on your master side. So yeah, and then these recorded changes will the basic requirement from the master side to the slave side. Disaster recovery. To record the changes is where we came up with something called going to be on your side. So same data center and a translator. A translator in Gluster means something reliable when it comes to natural calamity. So we go for provide the geo-replication where you can replicate your data across different data centers that are written on a particular. The requirements for geo-replication are recorded change. How do we get the copy of data from one Gluster volume for the geo-replication volume to the other place, replicated to the other side? So to do that, we came up and it's on the brick side. And I'll explain how requirements where flow goes. Checkpoints to know until when your data is actually the change logs have to be synced from the master side to the slave side to the slave side. And the other benefits of change log is to make this to create as efficient as possible to reduce the writes which are made, and each write is into a change log. Then you can say that if you have completed 5 change, basically we have change logs, then 5 of your writes are done. The master volume where you are actually writing your data from the master volume, and also if a particular data is copied onto your slave failing for some reason, we basically created 2 volumes and made use of them. Retry that particular write alone, and then the other thing is you have to record the changes that are going in on your master side, and then these recorded changes will be as you can see from the master side to the slave side, which is one particular Gluster volume in some trusted storage pool. Came up with something called change log. Content from the master volume will be synced across basically a translator. Slave volume. Translator is how basically geo-replication works as of today. Gets a certain input and provides a certain output. Yeah. So change log is going to get types of data. So the reason for crawl on a particular change logs get recorded as a recorded change, and this change is later on going to be one brick which I have explained sent for the geo-replication to so change replicated to the other side. Will be coming from the top, and it's on the brick side. It goes until the bottom where your flow goes. You have your disk there which is going to store your data. Change logs, the change logs have to be synced from the master side to the slave side. And change log is the other benefits of change log. Now I'm getting a write operation. Create checkpoints like if you have later on 10 writes which are made file, and each write is into a change log. Then you can say that if you have completed 5 changed on the incoming content, then 5 of your writes are done. Yeah, this is how we came up with the checkpoints. So these content will be available only if the geo-replication failing for some reason being a changelog, you can just enable when you create the volume. But there can be cases where you already have a volume, so and you want to sync the contents across to another volume again. So here you won't have your changelog. As you can see, so that's the reason we have this which is one particular Gluster volume in some trusted storage pool. Once you enable Georep on an existing master volume will be synced across to your slave volume. This is how basically Geo-replication works. Go through your file system, create pseudo changelogs, and these changelogs will be later on used to three types of crawl. Sync to the reason for crawl is and changelogs get recorded incoming traffic. It records the changelog and it syncs up to the one brick which I have explained. History is when you have a number of changelogs recorded, but your IOs will be coming from the top, and now you again started because the slave volume until the bottom where so all your recorded history will be there, which is going to store your data. And so when we do this through the bricks, it's going to pass through the diagram comes into the picture. You have the changelog translator in the right operation, which records the changes to the flat operation file, and then the agent process is going to read the contents from the flat file and give it to this worker, contents to a flat and worker is going to read the contents from the master and write it on to the slave. Yeah, and the worker and the agent are taken care by the monitor. These contents will be available only if the Geo-replication was so the disadvantages with the current approach is, but there can be cases where you already have a volume to identify and you want to sync the contents across to another volume. So here you it's going to be your changelogs, and so that's the reason we have this hybrid crawl. So this GFID is used to construct the whole file system. Once you enable Georep, so we are existing GFIDs from the master to the slave as well to construct this whole tree. Crawl is going to in this go through your dependency has been giving a number of issues, and these changelogs will be later on used to you can't sync to replicate it to a non-Gluster volume. And changelog crawl is you can have incoming conflicts between master and slave, and all those problems can be there. Slave you can't manually copy a file from the master to the slave. Right now it has to be done to a Gluster for some reason, and now you again started because the slave volume. And other than that, if you have a create, delete, and your recorded history, you have to repeat all these processes one after the other to have it in the right state. Is where this diagram comes into the picture. These issues, you have the changelog with something called in the brick, which records the changes to the flat file. And then the agent process is going to read the contents from the flat file. What this does is it stores your parent is going to read the contents from the master and write it onto the slave. This way, and the worker and the agent are taken care by the particular exata. So if one dies, the monitor spawns it again and so on. Give the path to the slave volume, so that the slave volume can work on the path. So we have something called a GFID to identify remove the GFID dependency. So the advantage is that you don't need a Gluster volume for the slave volume. You can write it to any of your other type of storage where you want to write it the whole file system. And so we are replicating the GFIDs from the master to the slave as well to construct this initial sync. You can copy files manually from the master to the slave. Has been giving a number of issues like create, delete, and create. We use rsync, which you can't just replicate it to a non-Gluster volume. You can these are the advantages of path-based Geo-replication, and all those problems can be there. Just and to you can't manually copy a file from the master to the slave. Right now, it has to be done to a Gluster volume through the Georep. So basically, and other than that, if you have a create, delete, storage pool I'm talking about, you have to repeat all these processes one after the other to have it in the right state. Two servers, and I'm creating a volume between these issues. We came up with something called as path-based Geo-replication, and we are working on it. So what this does is it stores your parent GFID in each file. I'm starting the master volume. Now this way we have a separate tool which can read this particular exata and then internally understand how the volume path is. So similar to this, I would have created a slave volume on another machine on the path so that I can instead of working on the GFID. Do the this way we have removed the GFID dependency. So the master volume is here on is that you don't need a Gluster volume for the slave storage pool. You can write it to any of your other type of storage where you want to write it, which you will have to repeat the same process. Yeah, you can use additional tools to do the initial sync. And I'm starting this particular volume from the master to the slave. So and you don't have to do a create, delete, and after that I'm mounting the master volume, and this additional volume that Georep is going to make use of. Yeah, these are the advantages of path-based Geo-replication, and I have a demo just to show how to have Geo-replication between two volumes in Gluster. So this is another command which you can make use doing a pure creating this particular volume. Storage pool I'm talking about that work. But so if you see, I'm having created this particular volume manually, and I'm creating a volume between two servers that you can called as the master volume, and I'm starting it. And then you can see that. So this command is going to, so you will need a passwordless SSH between your master and slave Gluster volume. I'm starting the master volume. So now I've done that. This is going to get the Geo-replication, which is used by Geo-replication SSH keys from various nodes in the master volume. This is another volume. And then send it to the slave volume so that the transfer can actually happen. I would have created a slave volume on another mission so that I can and other configurations for Geo-replication. So the master volume is here on these trusted storage pool, and the slave volume is on a different trusted storage pool, which you will have to repeat the same process. So you see that I'm doing certain configurations for Geo-replication, and then I'm starting a Geo-replication session over here, Georep uses, and then I'm checking the status. It initializes, I'm mounting the master volume, and this additional volume the Georep is going to make use of. So now I'll SSH to the slave node and show you the mount in the slave node to see what is the data available there. So this is another command which you can make use empty there instead of creating this particular volume. This command takes care of that work, but as I have done this, created this particular volume manually, this command is failing. But this is something that you can note to reduce this work. Yeah. So on the master, when I do an ls, you see nothing because I haven't created any file here. So you will need a passwordless SSH between your master and slave Gluster volume, one of the nodes. So I've done that. This is going to get you can see the slave volume here. Keys from SSH keys from various nodes in the master volume, from the master volume, and then send it to the I'm doing an ls on the slave. The transfer can actually happen through. I'm coming back to the master cluster, and I'm creating certain other configurations for Geo-replication. You can see the files in the master volume. I'm going back to the slave volume, and again I'm doing an ls on the slave. So which was empty, now it has these 10 files replicated here. So you see that I'm doing certain configurations for Geo-replication, and then I'm starting a Geo-replication session over here. This is how you do it. If you I'm checking the status, it initializes, and at one point it actually starts to work. So now I'll SSH to the slave node and show you the mount in the slave node to see what is the data available there. We haven't wrote any data, so it should be empty there. So you can see.
You said that you implemented path-based Geo-replication that doesn't use the GFIDs. So is it possible to use both?
So on the master, when I do an ls, you see nothing because I haven't created any file here. Work in progress. Now I am SSHing into the normal Geo-replication, which is between a Gluster volume to another Gluster volume. And so path-based Geo-replication, you can see the slave volume here. It's not yet completed. Which is a different volume from the master volume. So and I'm doing an ls on the slave. It's again empty. We will be mostly relying on path-based master cluster, and I'm creating certain files here. And now you can see the files in the master volume. I'm going back to the slave volume, and again I'm doing an ls on the slave. So which was empty. Now it has these 10 files replicated here. So setting up Geo-replication should be fairly easy in Gluster. This is how you do it. If you have any questions. Questions.
The changelog translator, does it have a performance impact if it's enabled? And could it be used for other purposes? Because, for example, we kind of want to track all file operations, kind of like an audit log, something like that.
So
changelog translator
it is not yet done. It's a work in progress thing. Right now you have the normal Geo-replication, which is between a changelog Gluster volume translator have a performance hit, and Geo-replication is something we are still working on. It's not yet completed. And yes, changelog will have a minimal impact, and we do give you options to. We will be mostly relying on path-based Geo-replication. You can say that I'll record a file for every 15 seconds, for every 15 minutes. So you have the ability to configure the time based on your volume. So that is something which with which you can tune your volume. And we are using changelog for yet another tool called Glusterfind, which is going to give you the files which have been changed from certain checkpoint to another checkpoint. So again, their changelogs are handy, so you can make use of changelogs for auditing as well.
The changelogs like complete? Like, can you trust does it have every performance will appear in the changelog?
Yes, changelog has been. So can you trust changelog is the question, and changelog has been there in Gluster for a while now. and it's pretty stable. So yeah, changelogs are
kind of like an audit log,
trustworthy,
something like that. So can the changelog translator be used for that purpose, and does it have a performance impact?
So the question is, does the changelog translator have a performance hit, and can it be used for auditing as well? And yes, changelog will have a minimal impact, and we do give you options to set the changelog. Like you can say that I'll record a file for every 15 seconds, for every 15 minutes. So you have the ability to configure the time based on your volume. So that is something which with which you can. Oh, you're asking if it is possible to get it back the other way. So the question is it only from master to slave, or is slave to master also possible? Tool called Gluster find, which is going to give you the files which have been changed from certain checkpoint to another checkpoint. So you can enable it the other way as well. Handy. This way you can copy your data back. But we don't have active mechanism right now.
Are these changelogs like complete? Like, can you trust that every file operation will appear in the changelog?
Yes, changelog has been, so can you trust changelog is the question, and changelog has been there in Gluster for a while now, and it's pretty stable. So yeah, changelogs are trustworthy. Thank you. So path-based Geo-replication is worked by Arvinda, and yeah, the Geo-replication team in Red Hat comprises of us. If you have any questions, I have the links provided in the slides. You can
active replication. Now
sorry,
it's like master slave, right?
Okay.
Is it possible to create like two sides master?
Sorry, is it possible to create?
I mean, like for havability. Now it's for disaster recovery.
Okay.
Right? So
you're asking if it is possible to get it back the other way.
Exactly.
So the question is it only from master to slave, or is slave to master also possible? Yeah, right now, once you stop your Geo-replication session from master to slave, you can enable it the other way as well. This way you can copy your data back, but we don't have active mechanism right now. Yeah.
Thank you.
Doesn't seem to be the case, and thank you, Hari.
Thank you. So path-based Geo-replication is worked by Arvinda, and yeah, the Geo-replication team in Red Hat comprises of us. If you have any questions, I have the links provided in the slides. You can make use of it. Thank you.